Hello. Yes. This is really exciting to be here for my first time in Dubai and to talk to you about this term that I coined. But before I begin, it's a bit unfair that I'm here on stage talking and I don't get to hear from you, because what I really want to do is learn from you guys. So just in case you have any questions or if there's anything that stands out to you, this is my Twitter handle and my Instagram. And I'll be sticking around afterwards, and I would love to hear your stories of how you're implementing big data successfully, or if you're struggling, talk to me. So I'm going to talk to you about the illusion of knowledge. And to talk about the illusion of knowledge, we need to go back a few centuries. In ancient Greece, when anyone, slaves and soldiers, poets and politicians, had to make a decision on life's most important questions, like, should I get married, or should I invest in this voyage, or should we advance into this whole new territory? They all sought the advice of the oracle. So this is how it worked. You would come to the oracle with a question, and then you would ask it, and then she, the oracle, would go into this trance, and she would stay in this trance, not for minutes or hours, but for days on end. And then all of a sudden, after days, she would come out of her trance, and then she would give you her answer. And then you would know what to do. So from the oracle of ancient Greece to the oracle bones of China to the Mayan calendar, people have craved prophecy in order to find out what happens next. And that's because no matter what, after centuries, we all still want to make the right decisions, because we don't want to miss something, big, because the future can be very, very scary. And it was just as scary as it was thousands of years ago as it is right now. And it's much nicer to believe that we can make our decisions based on some assurance of the outcome. And now we have a new oracle, and its name is big data. And it has other names too, like Watson, like deep learning or neural nets, whatever you want to call it. And that's because we live in the age of data-driven decision making. And these are the kind of questions we can ask of our oracle now, like what is the most efficient way to ship a phone from China to New Zealand? Or what are the chances that my child might be born with a genetic disorder? Or what percentage of our aging population will have heart disease? And governments all around the world are using this oracle, or different forms of it, to answer really important questions. I'm from the United States, and I know that we have all these new technologies. Other countries have many, new ones and better ones too, but just to name a few, I know now we can actually detect breast cancer through MRI detection better with the help of algorithms. In California, we've had a terrible, terrible problem with wildfires, and now we are using AI to track recovery records, recovery efforts, and to actually do real-time housing needs. The Social Security Administration in the United States is using massive amounts of unstructured data to analyze it, to look at fraudulent claims, and to more efficiently process disability. Now, because of all these amazing things you can do with big data, this has become a $166 billion industry. Now, this is humongous, but despite the size of this industry, the returns are surprisingly low. The majority of big data projects are not profitable, and that number sits at 73%. This is an absurdly high number. How is this possible? And why are we not talking about this? Why is everyone talking about how amazing big data is, but the reality is that about 75% of them are failing? So I speak at a lot of conferences about big data and how to use big data. And always after all my talks, some executives of corporations or leaders of governments come up to me and they whisper. They come up to me by themselves and they whisper, and never in front of everyone. They go, guess what? Tricia, we made an investment in big data. Some company promised us they were going to help us find out all the things we ever need to know about our citizens, how to help them, or about how to make more money, what our customers would want. And we don't know if we actually know any more than we did. And they whisper this secretly, and they say, why is that? And I tell them, it's not your fault. My company, Sudden Compass, we help other companies, enterprises, and organizations implement big data in a human-centric way. And we've worked with a lot of entities, but no matter what, the heart of their question that they come to us with is the same thing. They're constantly asking us, how do we do more with our data? We have so much of it, but I think we're actually not doing enough with it. And why is that? Why are we struggling? And the answer is that investing in big data is easy, but using it is hard. It is very easy to buy a big data dashboard, spend a couple $1 million on hiring the best big data scientists, but no one ever wants to talk to you about how to actually use big data and what are the practices. So this is all really interesting to me because I'm a technology ethnographer. And it's okay if you don't know what a tech ethnographer is. It's because I made up the term to make up a new job title for myself that didn't exist. And all it means is that ethnography is the science of observing people. So I observe what people do with technology. And one of my interest areas is trying to understand the new role of data in society. And I've noticed with all these executives coming up to me and all these government leaders, when they started coming up to me, they started telling me that they're struggling with data. What I started seeing is that having more data does not automatically lead us to making better decisions. We've been told a lie. We've been constantly being told a fallacy that it just isn't true. And their data science companies are trying to tell you and sell you on the idea that automatically just collecting more data by itself, you will find out the truth. And there's nothing more wrong or farther from the truth than that statement. And I witnessed this struggle firsthand about 10 years ago, before big data became a thing. Back in 2009, I started out as a researcher in R&D labs at Nokia. And at the time, Nokia was one of the largest cell phone companies in the world, dominating emerging markets from China, Africa, Mexico, India. And I was studying how migrant populations were using technology. And I spent a lot of extra time in China where I got to understand the informal economy. I lived and I worked with street vendors and with migrants. So this is a picture of me selling dumplings as a street vendor. This is what ethnographers do, if you're wondering, is that we do whatever people do. So if I'm studying migrants who work in construction, then I also work in construction. If they sell dumplings, then I end up selling dumplings, and I blend in with everyone. And I also slept in internet cafes to understand how Chinese use internet. And through all of this qualitative evidence of spending time with people, observing people, I started to realize that lower-income Chinese people were using technology in a way that was going to be very different than what Nokia was thinking in the future. And I could clearly see that a big change was coming. All these poor, people that Nokia thought that they were selling their phones to, all these migrants were being surrounded by luxury ads like this, by luxury ads for bathroom appliances, of apartments and cars. And through conversations with all the migrant youth that I was spending time with and migrant adults, I found out that it was actually advertisements for things like iPhones that enticed them the most, promising them entry into the high-tech world. And even when I was living alongside people who lived in urban slums just like this, this was the bathroom that I had to use every day for about a year. I would walk past this. Even these people were saying, we are saving up our entire year's salary to buy an iPhone or to buy a smartphone. And this is shocking. This is 10 years ago, before smartphones were a thing. And when you look at neighborhoods like this, you wouldn't imagine people who live here to be wanting to be high tech. And increasingly, people were saying, you know what, maybe I don't have to spend a year of money to buy an iPhone. Maybe I can just save up, a couple months of salary to buy a Shanzai phone, which means it's an affordable knockoff of an iPhone or a smartphone. So if you read the label carefully, you'll notice that something is off, and that's what Shanzai phones are. And after years of living with migrants in their homes and, working alongside them, I realized, you know what? They're going to want to buy smartphones. And I was really excited to tell Nokia this. And you have to keep in mind, this is right when smartphones were introduced. And a lot of smart people said the iPhone is just a fad. No one is going to invest that much money in it. Very smart people thought that. And so, but I said to Nokia, look, I'm very confident of my data that eventually your entire market is going to disappear if you don't start moving into the smartphone category. And Nokia said, that is crazy. We have millions of data points that do not indicate anything about any of our customers wanting to buy smartphones. And they said, oh, Tricia, your sample size of 100 people that you studied over 10 years, living with them, breathing, doing everything with them, well, maybe that's very small data set compared to our millions of people. And I said, you're right. My data set is much smaller, but it's much thicker, and it has a lot more depth. And you're not going to find my insights in your data set because your data set is collected on the assumption that no one knows what a smartphone is, and your data set is designed to optimize for a business model that doesn't exist right now. And I'm looking at human dynamics that exist outside of the market. So if we can get ahead of it, then we can actually collect different kinds of data to back up my data. And they said, oh, we don't want to do anything with it. And do you know what happened to Nokia? Yes. Their business fell off of a cliff. This is the cost of missing something, because they were so busy looking at the right data to fit their models that they never bothered asking the right questions. Now, not everything valuable is measurable. Nokia was so blinded by their own data that it was inconceivable to them that low-income consumers who had always paid a certain price point for phones could suddenly just change their behavior. You may think, well, that's just a corporate story. But I can tell you, I've seen countless times how of this happening in the public sector. And in these cases, we're not talking about that red line is a loss in profits, but when it comes to governments making that decision, that red line can be oftentimes a loss of lives, it can be a loss of trust, it can be a loss of many things that have nothing to do with just straight up monetary value. I see organizations throwing out data that doesn't fit their models all the time. Then a lot of people say, well, are you trying to say it's big data's fault? And I said, no, it is not big data's fault. It is the way we're using big data. Just relying on big data alone increases the chances that we'll miss something while giving us the illusion that we already know everything. And what makes us so hard to actually see and even wrap our minds around is that we have a problem called the quantification bias. This is the unconscious belief of valuing the measurable over the immeasurable. And we often see it in our work. It's when someone becomes so focused and so obsessed with their model, with the numbers, that even when you give them evidence that doesn't fit in their model, if you give them something that doesn't fit in the form of numbers, they can't even see it. And that is the quantification bias, and it is alive and well. And this bias is reinforced by big data companies that say, our machines, our dashboards, our algorithms can help you quantify everything, and it can help you find that needle in the haystack, that single source of truth. But quantifying things can be addictive because once you start, it's easy to get rid of any kind of data that can't be expressed as a straight-up number. And it's easy to fall into silver bullet thinking that, it's just a simple solution. If we just had everything as a number, then we can figure out the right decision. Because oftentimes, the future we may need to predict, it isn't in the haystack, but it's actually that tornado bearing down on us outside of the barn. There is no greater risk than being blind to the unknown. It can cause you to make the wrong decision. It can cause you to miss something big. But we don't have to we don't have to make the same mistake over and over again. It turns out that the Oracle of ancient Greece actually holds the answer to our solution. So if we go back to ancient Greece, actually recent geological evidence shows that the Temple of Apollo, where the oracle sat, actually was the home of, two geological earthquake faults, the Kurna Fault and the Delphi Fault. And what happens around these earthquake faults is that it was actually releasing fissures of gas, of ethylene gas, into the air. And so the oracle sat right above these fissures and was inhaling enormous amounts of ethylene gas when she was making her predictions. So when she was actually hallucinating the whole time when she would go into this trance for days. So the point is, when she actually would give her answer when she was in this trance, high on ethylene gas, how did she ever give any useful data, right? She was high as a kite. So how does anyone get any useful data out of this? Well, here's the thing. If you look back to this picture, see all those people surrounding the oracle, right? There's this guy with the orange notebook in the back. So when the inquisitor came and say, hey, I have a question, should I get married or should I make this investment? The people behind her would actually ask the person, why do you want to know this answer? What are you going to do with it? Tell me about who you are. They were the modern ethnographers trying to find out the context of the actual question. So the oracle was never working alone. She always had a team of people helping her figure out how to interpret the actual answers. So to be clear, I'm not saying that using big data systems and huffing gas is like huffing gas or like people giving invalid predictions. But what I am saying is that in the same way that the oracle needed her temple guides to actually give accurate predictions and answers, our big data systems need them too. And these are the people, there are names for them. They are called ethnographers, researchers, they're called UX designers. These are the people who help you gather what I call thick data. Thick data is precious data that comes from humans. It comes in the form of stories, emotions, and it comes in the form of interactions that are difficult to understand in the form of a spreadsheet and that cannot fit into a database. And it's the kind of data that I collected for Nokia. And it's the kind of data that that all of you need, and that all of us need to make better policy decisions, to make better business decisions. And thick data comes to us in the form of a very small sample size, but it also comes with an incredible depth of meanings. And this is why we need both. It's not about thick or big data. To actually form a more complete picture, we need both. Big data gives us insights at scale, and it takes advantage of machine intelligence, whereas thick data comes to us in the form of really deep, small sample size, and it comes to us in the form of using human intelligence. And when you integrate both, that's when things can get really fun and exciting, because you no longer are just working with the quantitative data. You can actually start answering why. Why is certain data showing up in a certain way? And you get to actually then answer questions about unknown human behavior. This is a selected highlight of a side-by-side of a few factors and differences of how you can understand, what we at my company share as a difference between big data and thick data. And the thing is, in schools, we're taught you have to pick one side. You're either a hard science person, right? You're either an engineer or a chemist or a computer scientist, or you're on the soft side, you're a communications person, you are into anthropology, marketing. And then when you go into organizations, everybody's split in half. And everything in governments and organizations prevents the people on this side from talking to the people on this side. And then you can see how the problems begin, is the people who work on the machines don't understand the humans, and the humans have no idea what the people are doing with the machines. And that's how the problems begin. And so this is why we have to destroy this idea that it's either big or thick data. The value is in the integration, and that's why my company, Compass, we created a new movement called integrated data thinking. Now, if you're probably wondering, how do we do this integration? Before the end of my talk, this is, I would say, one of the most important slides to capture. This is a slide coming out of our lab where we teach organizations how to start. And We always say this is probably one of the most important questions that anybody can ask when you want to integrate big and thick data. The question is, how do we best mathematically scale human models into reliable and meaningful data models? And what this means is that this is what closes the gap to ensure that when you're building a data model, it's built on the thick data, the thick understanding of a human model. And that's when you close the gap and do really great stuff with big data. It means nothing if you don't start with the human model. And I want to give you a quick example before I leave the stage. A few years ago, I was chatting with one of the most beloved Swedes that's ever lived. His name is Hans Rosling, and one of the world's best statisticians to ever live. And we were talking, he was telling me how proud he was to be the chief advisor on Ebola epidemiology in the Ministry of Health and Social Welfare in Liberia. And I want to share this quick story because it's a great example of how you can't just use quantitative data. Rosling was given a lot of credit for solving Ebola. The news said people like Rosling, statisticians, and companies like IBM using big data have gone into Liberia to liberate the world of Africa from Ebola. And they solved the problems with numbers and computers. And Rosling said, this is all wrong. He actually used some curse words, but he was very upset. And he said, it's not true at all. He's like, this is not about big data. It's about big anthropology. I'm not interested in data. I'm interested in people and life. And he told me that the actual secret to solving Ebola was a man named Musaka Fala, who was called the Ebola hunter. And he's an epidemiologist. And Fala was in charge of contact tracing of the Liberia outbreak. And it was his identification method and diagnosis that he used to help understand the source and the contact tracing to solve and break the Ebola outbreak. And you may remember that part of the problem was that that they couldn't stop Ebola outbreak because people were afraid to go to the hospital for treatment. Well, Fala was the one who figured out why. He actually said, I'm just going to go directly to the places where the Ebola outbreaks are the worst, like, for example, the township of West Point where he grew up, and he went into conversation with people face to face, and he talked to them. He brought dried fish, he brought water, and he brought goods, and he sat down with people and looked them eye to eye and said, what's going on? And people just said, look, I have Ebola, probably, and I'm too afraid to go to the hospital because I don't want to be quarantined. And then he was like, oh, so you don't trust the hospitals. And then that's when he was able to understand why people were not going. And it was his thick data insights that helped contain the outbreak. And he talked to individual communities, and through the communities, they created a whole entire new participatory model to understand how to track the data. And then they went back to the data scientists, then they went back to Hans Rosling and said, let's create a model, a quantitative model, to look at my human model of how to do the outbreak. And all of a sudden, there was a drop in new cases of Ebola in Liberia. And many of the Ebola treatment centers that were being built by Western institutions remain empty, but it was Ebola and Musaka was able to solve it. Because instead of making sure, and they actually closed this gap by building a data model built off of a human model understanding of why people weren't reporting when they actually had Ebola. It was a matter of trust, and Musaka was able to solve it. Many organizations think now that we have big data, we can just skip the human part, but that is a grave, grave mistake. We have to start building data models from the very beginning. And one of the companies I advise, which is it's called Disaster Intelligence, they're an emergency management company. They also use algorithms and deep learning, and all of their work, they work with governments all around the world on disaster management. And they do the same thing for predictive forecasting and modeling as Musaka and Fala and his team do. And you can do this too, no matter where you are in your data journey, whether you use artificial intelligence or you're just using an Excel spreadsheet. The number one thing you can do is get out of the building. Do not think you can solve a problem by just looking and understanding your citizens in a spreadsheet. You must leave and you must talk to them. And the people who talk to them most, talk to those people and find out what are they learning. Never trust just the numbers. That is only half of the story. You have to find out why, and you can never understand why from just a spreadsheet. And lastly, find like-minded partners. partners. Work with people who also value talking to humans and finding the thick data and building a data model off of it. And when you do all of these three things, you are on the right path to using big data and integrating with thick data. And as our lives become more automated, we have to understand that all of us are going to be affected by the quantification bias. The good thing is that we've come a long way from huffing ethylene gas. We now have machines, we now have computer science, we now have things that can help us with this integration. The question is, are leaders, our government leaders, brave enough to put the right people who know how to use thick data and empower them to actually answer questions? And are we ready to actually say, show me more than just the numbers. Tell me what the stories are. Tell me what's missing in the numbers. We have a lot of problems to solve, so let's make sure that we use data to make better decisions, better outcomes, better societies, and a better world. Thank you so much.